Hello, my dear students. I welcome you all to my channel. So let's continue with the same chapter on relation and function. So far we have learned about ordered pairs and Cartesian product. Alright, so with the assumption that you have understood Cartesian product, let's begin. Okay, so the topic for the day is relation. Okay, so let's understand what's the meaning of relation. So let A and B be two non-empty sets. Then a relation R. Okay, so relation is denoted by R from A to B. Okay, so for any relation we need two objects, whether this is in between humans or in between any other objects. Alright, so since we are dealing with sets here, so here we are going to talk about the relation of one set with another. So here relation R is from A to B. So this is how we represent. Okay. Now this relation from A to B is a subset of A cross B. That is the subset of Cartesian product. Now if I ask you what is the relation of what is the relation R from B to A? Then you must say that relation R from B to A is a subset of B cross A. Alright, it's not going to be A cross B. So basically whichever is your first set, that will come in the front, and whichever is second set, that will come at the back. Alright, so let me repeat once again. If A and B are two sets, then a relation R from A to B is a subset of A cross B. Now let's try to understand this definition using example. Okay, so I'm giving you two sets here. So these sets we have already seen in the earlier video. Okay, so A is ABC. A is a set containing ABC, and B is a set containing Abhay, Ankit, Vedant, Chandan and Dipesh. Okay, now I'm defining one relation. So as I said, this relation is subset of A cross B. That means in this relation we have the objects as ordered pairs. So we see that this relation contains, this is a set which contains ordered pair. This is the first element and this is your second element. Now here relation is defined in this way. In the first, that is the first element should be alphabet. Okay, so alphabets are given here, and the second element has to be the name with the same alphabet. Now what's the meaning of this? Let's try to understand. For example, this relation, if I write this in tabular or roster form, that means if I list all the elements, then if I start with alphabet A, okay, so let's see what are the names which begin with A. So the names which begin with A are Abhay and Ankit. So that's why A Abhay and A Ankit will come within this relation. Alright, now we don't have any other name starting with A. Now let's see the other alphabet. The other alphabet is B, isn't it? So the name which begins with B is only Vedant. So that's why B comma Vedant will also come in this relation. Alright, now C. Okay, so we have the alphabet C and the name starting with C is Chandan. So that's why C Chandan will also come. Now we don't have any other alphabet out here. So that's why these are the only I should say ordered pairs which belong to this relation R. Okay, so now let's see what was our A cross B. So in the last class we have seen that A cross B is this set, isn't it? Now the definition of relation said that this R is a subset of A cross B. Now if you see here, you clearly see that all the elements of this R is taken from A cross B, isn't it? So that's why this R is a subset of A cross B here. That is, R is the relation from where? From A to B. So that's what is the meaning of this definition. Alright. Okay, so clearly R is a subset of A cross B. Okay, so one thing to note here is if n of A is equals to P and n of B is equals to Q, then total number of possible relations from A to B. See, there are many relations possible, all right? So how many possible relations are there? That will be given by this number, that is 2 to the power PQ, all right? So you need to make note of this. So pause the video and note it down. Okay, now let's understand what is the meaning of domain, range and codomain of a relation. Now you know that in a relation, what kind of elements are there? We see that the elements are ordered pairs, isn't it? Because it is a subset of A cross B. So that's why relation contains ordered pairs. Alright, so let A and B be two non-empty set and let R be a relation from A to B. Okay, then domain is a set. All right, so you can clearly see that this is a set of first element. See, x comma y belongs to R, that is belongs to the relation, and if I choose all the first element and put in a set, then that gives you the domain. All right, fine. Now the range. Okay, so range is defined as the set of all second elements. Okay, so second elements are y, so if I put all the second elements within a set, that gives you the range. All right, now what is codomain? Codomain is the second set. This thing you need to remember. Now let's try to understand this using the diagram. Okay, so this is my set A and this is my set B. All right, so set A. Okay, so there's a relation R from A to B. Okay, so the first set is known as your domain. Okay, so this entire set B is known as your codomain. And the part of the codomain, okay, the part of the codomain which is being mapped with the elements of domain, that means x is getting mapped to y, isn't it? So if I consider that these are the only y's, okay, then this part gives you the range. All right, so basically from the diagram you clearly see that range is the subset of codomain. All right, so you need to remember this thing, that is range is a subset of codomain. Okay, fine. So after understanding the relation, now let's try to understand what is inverse relation. Okay, so let A and B be two non-empty set, let R be a relation from A to B, then the inverse of R is denoted by R to the power minus 1, and this is read as R inverse. Okay, so R inverse is a relation from B to A. Okay, so if R is the relation from A to B, then R inverse is the relation from B to A. And how it is defined? It is defined in this way. That means if A comma B is a part of R, then B comma A is a part of R inverse. All right, so that's what we need to remember. Okay, so one thing that you need to remember is, see, A comma B belongs to R, isn't it? That means if I put all the first element in a set, then what do we get? We get the domain of R, isn't it? Now, if I ask you what is the domain of R inverse, then you will say that set of first element. Now, what is the first element in R inverse? B, isn't it? B is the first element in the R inverse. So that's why domain of R inverse is B here. All right. Now, if I ask you what is the range of R here, you will say the second element, that is B is the range of R, isn't it? So that's why, see, here B is the range of R and B is the domain of R inverse, isn't it? So that's why it is written range of R is equals to domain of R inverse. Now similarly, if I ask you for R, what is the range? Okay, I'm sorry, for R inverse, what is the range? If I ask you, then you will say second elements give you range of R inverse. And what are the second elements of R inverse? It is A. But for R, the first element is A, and the first element gives you always domain of R, isn't it? So that's why domain of R which is A, is equals to range of R inverse, which is also A. So clearly we need to remember this thing as well. Alright, so pause the video and note it down. Alright, so having understood the definition and examples on relation, let's begin with the sums. Okay, so I am taking exercise 2.2 and the first question for the day, I am taking question number 3. Okay, so the question says, given A is this set and B is this set, find the number of relations from, there are 4 parts given. Okay, so in the first part you have to find how many possible relationships are there in between A to A. Alright, so the formula says, so for finding the number of relationship possible in between two sets, the formula is 2 to the power pq, where p stands for the number of elements in the first set and q stands for the number of sets in the second set. Okay, so number of elements in the first set is given to you 2 and the number of elements in the second set is given to be 3 here. Alright, so number of relations from A to A, this is the first part, it will be given by the formula 2 to the power pq, and as I said, this p stands for number of elements in the first set. So what is my first set? It is A, right? So in this case this p is equals to 2. Alright, into q is there. Now what is second set here? Second set is also A, right? So that's why the value of q is also 2. So how much is this? This is 2 to the power 4, and how much is 2 to the power 4? 2 to the power 4 is 16. That means the number of relations from A to A will be 16 for us. Alright, now the second case says find the number of relations from A to B. Okay, so again the formula is 2 to the power pq. Now p is the number of elements in the first set, and what is set here? First set is A, so that's why the value of p is 2. Alright, into B. Now second set is B, so that's why the value of q will be how much? 3. So it is how much? 2 to the power 6, and what is the value of 2 to the power 6? It will be equals to 64. Alright. Third part says number of relations from B to A. Now the first set is B, so that's why my P is 3. Second set is A, so Q is 2. So that's why my value will be 2 to the power 3 into 2, which is again 2 to the power 6. So this is also 64. Alright, so the last part says find the number of relations from B to B. So first set is also B, second set is also B. So that's why here both P and Q will be equals to 3. So that's why my answer will be 2 to the power 3 into 3, which is 2 to the power 9, and the value of 2 to the power 9 will be 512. Alright, so this will be the answer in this case. Now one thing I want to say here is, sometimes you may see that relation is defined on A. So sometimes only this part will be written. But for any relationship, we need what? We need two sets, right? But here it is defined only one. Only one set is given. So if this is seen anywhere, this means that relation is from A to A itself. Alright, so that's what is the meaning of this. Now, having understood this problem, now let's move on to the second problem. So second problem says, that is fourth problem for the day, fourth question and second problem for the day. So this is given to you, this is the relation. Alright, so this relation is given in your roster form. Okay, so we know that in a relation we have elements to be ordered pairs, isn't it? See, this is one ordered pair, this is also ordered pair, this is also, so all of them are ordered pairs. So this gives you the relation, and from this relation you need to find what is domain and range as per the question. Okay, so domain means for all the ordered pairs you choose only the first elements. For example, from this the first element is -2, isn't it? So if I put all the first elements in a set, that set gives me the domain of the relation. Alright, so that's why we have -2, the first element, second element is 0, 3 is there, 0 is already written, we cannot repeat it, so we have got 4, and next is 5. Alright, so this gives me the domain of this particular relation. So next we have is range. So if you collect all the first element, then you will get domain. Now if you collect all the second element, then you will get the range. For example, the second set here, second element is 1. Yes, next is 2, next is 1, which is already written, next is minus 1. Yes, next is 2, 2 is also written, and next is 1, so 1 is also written. So this gives you the range and this gives you the domain for this particular relation. So pause the video and note it down. Okay, let me take question number 7. So question 7 says, given A equals to this set and B equals to this set. Okay, and the relation is defined in this way. Now let's try to understand what is the meaning of this relation. So in this relation we have ordered pairs, okay, and from where does this ordered pair coming? This ordered pair is coming from A cross B, that is Cartesian product of A and B. Okay, now what is the meaning of this? Let's try to understand. The meaning of this is that the first element is coming from A, okay, that means X should be chosen from A, okay, and this Y is coming from B. Alright, now how this X and Y are related, that also should be known, isn't it? So it is given that X is a factor of Y. Alright, now if this is the given relation, now you have to write this relation in roster form. Alright, so that's what the question is asking. So let's see how do we write the roster form for this. Alright, now the roster notation for R is, so let's see. Okay, so the first is X, right? So first we have to write X, and from where do we need to choose X? This X has to come from A, isn't it? So let me choose any elements, the first element of A, that is 2. Now it is said that this X is a factor of Y and this Y is coming from this. Yes. Now from B I have to choose a number, okay, such that X is a factor of that particular number. For example, if I choose 4, can I say 2 is a factor of 4? Yes, so 2 is a factor of 4, so that's why 2 comma 4 comes in this relation. Alright, now again let's see whether we have got any other number whose factor will be 2. For example, we have got 6, isn't it? Because 2 can be considered the factor of 6, so that's why I can include 2 comma 6 as well. Now I cannot put 2 comma 9. You know why? Because 2 is not a factor of 9. Okay, so only these two are coming for 2. Now let's choose 3. Now if I choose 3, then I have to choose 6 from here, because 3 is a factor of 6, isn't it? Similarly, we can take 3 and 9. But we cannot take 3 and 4. Alright, so this is again, these two also belongs to this relation, right? Now if I choose the third element, that is 4, now with 4, or yes, so with 4 I can choose only 4 from here, you know, because I can call this 4 as the factor of 4. 4 cannot be the factor of 6, remember that. Alright, there is a common factor, that is 2. 2 divides 4 also and 6 also, but 4 does not divide this. Okay, so what is the meaning of X is a factor of Y? It means that Y is divisible by X. Alright, so that's why I cannot include 2 comma 6, because 6 is not divisible by 4. So this will be the roster notation of this particular relation. Alright, fine. Now let's move on to the 9th question. So question number 9 says that, okay, so let me read the question for you. Okay, so question says, if A equals to this set and R is a relation on A, okay, so it is said R is a relation on A. Now what is the meaning of this? This means that relation R is from A to A, alright, okay, and this R is defined in this way, alright. You need to write this relation again in roster form. Okay, so you will again write the roster notation Okay, so it is said that R is related in this way. That means what is this? This will be equals to 3x equals to y, isn't it? Or else I can say that from here we have y equals to 3x. Okay, so let us choose x because the first element is x. Now if I choose x to be 1, then what will be the value of y? Y will be 3 into 1, which is 3. Now is this 3 belonging to this? Yes, isn't it? So that's why I can take 1 comma 3. Alright, now let us take another value for x. Another value for x will be 2. Alright, now 2 into 3 is 6. Now is 6 present in this set? Yes, so 6 also comes here. Next is the value of x becomes 3. So we have 3 into 3 is 9. 9 is also present here. So that's why this will also come in this relation. So similarly, the next value for x will be 4. So 4 into 3 is how much? 12. So 12 is also present here. So this will also come here. Next value for x will be 5. So 5 into 3 is 5 into 3 becomes 15. Again 15 is also present. So this will also come. Now if I choose 6, if I choose x to be 6, then 6 into 3 is 18. But 18 is not present because in this set we have got the numbers from 1 to 17 only. 18 is not present. So that's why I cannot take 6 comma 18. Alright. Next is 7. Obviously 7 into 3 is 21, which is also not present. So basically from here onwards we cannot take any other elements. So these are the only elements which are present within this set. Alright, so this will be the roster notation of this particular relation. So pause the video and note it down. Alright, so let me take the next question. So question 12 says that given is this relation. So there are two parts asked here. So the first part says find the domain and range. So domain and range is very simple. Yes, the domain sees that we need to include all the first elements. So in first element here is 1, here it is 2, here it is 3, here it is 4 and 5. So this gives you the domain for this particular relation, and the range is given by the set of all second elements. So here the second element is -1, here it is 0, here it is 1, here it is 2 and here it is 3. Alright, now we need to, in the second part, we need to write down the very same notation in roster form, in set builder form. Okay, now whenever we write set builder form, our form will be somewhat like this, isn't it? So we have the roster form will be somewhat like this, x comma y, yes, such that now we have to write some relationship between x and y. For example, either x can be less than y, or there can be any other pattern in between x and y. So that's what we need to search for here. Alright, so let's see what will be the pattern out here. So we have, okay, so let's start from here. So what is the difference out here? 5 minus 3 is 2, isn't it? Yes. We have 4 minus 2 is also 2. Yes. So we have 3 minus 1 is also 2, 2 minus 0 is also 2, and 1 minus of minus 1 is how much? So 1 minus of minus 1 will be 1 plus 1, which is 2. So again this difference is also 2, right? So this is what we can see here. Alright, so the relationship between x and y, see the first element is x and the second element is y, isn't it? So we see that x minus y is giving me 2, isn't it? Okay, so we see that every element in R, that is this relation, follows a pattern, isn't it? That is first element minus second element is equal to how much? 2. So this is the pattern that we see from the given relation. Okay, so therefore you'll write therefore the roster notation, the set builder notation, therefore the set builder notation of R is, okay, so it will be R equals to x comma y, so such that we have the first element x minus y is equals to how much? 2. Alright, and what is this x? This x is coming from this set, isn't it? And what is this y? This y is coming from this set. Alright, such that, okay, where, okay, so x is coming from, we have x is coming, okay, so let me write this domain as A, okay, and let me write this range as B. So where x belongs to A and y belongs to B, that is the range. Alright, so this will be the notation for this relation in set builder form. Alright, now the next question says, so next question says, from question number 16, we have, from the adjoining diagram, or the adjoining diagram shows a relationship between sets P and Q. Okay, it is given P and Q, but in diagram it is given A and B, so that's not P and Q, that is A and B. Alright, write this relation in roster form. So this relation has to be written in roster form. After that, write it in set builder form, and what is its domain and range. Alright, so this is the first set and this is the second set. So this arrows gives you the relationship. That means 5 is related to 2. Alright, that means, this means, okay, so the first one is the roster notation, isn't it? Yes, so therefore number 1, roster notation of okay, so if you see here, first element, see the first set is A, right? So we have ordered pairs here, isn't it? So in this ordered pair, we have the first element coming from the first set. So the first element from the first set here is 5, and this 5 is related to 3, isn't it? Because the arrow shows that 5 is related to 3. So 5 comma 3 will be the first element. Next will be 6 comma 4. Next ordered pair will be 7 and 5. So these are the only ordered pairs that can be formed here. Alright. So next is the set builder form. Again, let's see if there is any pattern out here. So what will be the difference here? So again, 5 minus 3 is 2. So this is 2. So this is also how much? 2. So this is also 2. So we see that the difference is 2. So that's why again the set builder notation will be similar to what we have done just earlier, right? So set builder notation will be, okay, so set builder notation will be your, okay, so x comma y says that x minus y is 2. First element minus second element will be 2, and or you can write comma out here. So this x, the first element comes from where? From A, isn't it? So x belongs to A, and this second element y is coming from where? Y is coming from B. So this is your set builder notation. Now at last you need to write the domain and range. So domain will be 5, 6, 7, the first set, and the second set gives you the range. Alright, so number 3, domain is the first set, isn't it? And range is the second set, that is B. Alright, so pause the video and note it down. Okay, let's take question number 18. So question 18 says, let R be the relation on N, that is N is set of natural numbers defined by this one. Okay, so question says, list first question says list the elements of R. So listing means what? You have to write the given relation in roster form. Okay, so that's what we are going to find in the first one. Second one is find the domain. After finding the roster form, domain is easy, and similarly you have to find the range. All right, so let's see how to do this sum. Okay, so here this A and B is related in this manner. Okay, so since A is coming from natural number, so let's see what will be the first element. So the first value of A can be taken to be 1, isn't it? Because the natural number always start with 1. So if I choose A to be 1, so from here, let's see what will be the value of B. So from here, the value of B will be, this A goes over there, so 12 minus A whole divided by 3. Okay, so if I choose A to be 1, so let's see how much do we get. So we get 12 minus 1 is 11, 11 by 3. So 11 by 3. The value of B turns out to be 11 by 3, and now B also has to be a natural number. But 11 by 3 is not a natural number, so that's why I cannot choose A to be 1. Alright, now let's take another value for A. If I choose 2, then we have 12 minus 2 is 10, so 10 by 3. So again that is also not natural number. So let me choose A to be 3. Okay, so it is 12 minus 3 is 9. So 9 by 3 is 3, isn't it? So B is also turning out to be 3. So when the value of A is 3, then the value of B is also turning out to be 3, and both are natural numbers. So 3 comma 3 will be the first element of this particular relation. Okay, now let's take another value for A, that is 4. So 12 minus 4 is 8, 8 by 3 is not a natural number. So go for 5, so 12 minus 5 is 7, 7 by 3 is also not natural number. Take A to be 6, so 12 minus 6 is 6, so 6 by 3 is 2. So we can take the value of A to be 6, and when A is 6, the value of B will be equals to how much? 2. Alright, now next value for A will be 7. So again 12 minus 7 is 5, 5 by 3 is not possible. So next is 8, so 12 minus 8 is 4, 4 by 3 is also not possible. Next value for A is 9. So 12 minus 9 is 3, so 3 by 3 is 1. So another element will be 9 comma 1. Alright, now next is 10, right? So next value for A is 10, so 12 minus 10 is 2, 2 by 3 is not a natural number. Next is 11, yes, the value of A will be 11, so 12 minus 11 will be 1, 1 by 3 is also not a natural number, right? Now next value will be 12, so 12 minus 12 is 0, so 0 by 3 is 0, but B equals to 0, that is 0 is not a natural number, so that's why we cannot take. Now if you cross 12, then you will get negative numbers. So again negative numbers are also not natural numbers, so only these many ordered pairs, that is 3 ordered pairs, forms the roster notation or forms this relation. Okay, so we got the roster notation. Now we need to find its domain. So domain will be 3, 6, 9. Okay, and the range will be 3, 2, 1, or you can write this as 1, 2, 3 as well. Alright, so this will be your range. Now next problem is question number 19. So question 19 says, if R given in this way, then find the domain and range of R. Also write R in roster form. So you need to find domain and range, and you need to write roster form as well. And it will be easy for us if we first find the roster form and write down the domain and range. Alright, so let's see. So here this time, see here it was given that A and B were natural number, but this time X and Y both are whole numbers. So it is also like natural number, but we have to include 0 as well. So whole number starts with 0, 1, 2, 3, 4 and it continues. Okay, so this means that R will be, okay, so the first one, so we see that here x square plus y square is 100, right? So let me write y will be equals to, from here, 100 minus x square, square root of 100 minus x square, isn't it? Yes. Okay, so let's choose the first value of whole number to be 0. Okay, the value of x start with 0, so 100 minus 0 is, okay, 0 is square is 0, so 100 minus 0 is 100 and square root of 100 is 10. Yes, so the value of y turns out to be 10, which is also a whole number. So that's why the first element here will be, when x is 0, the value of y turns out to be 10. Alright, next is 1. So it will be 1 square, so 100 minus 1 will be 99, and square root of 99 is not possible, so that is not a whole number, isn't it? Square root of 99 is not a whole number, so that's why we cannot take the value of x to be 1. Similarly, go for 2, so 2 square is 4, so 100 minus 4 is 96, and we cannot find square root of 96, so that's why that's also not possible. So next is 3, 3 square is 9, so 100 minus 9 is 91, so 91 is also not possible. Yes, and the next is x equals to 4, so x equals to 4 gives you 16. Yes, so this is x square is 16, so 100 minus 16 will be 84, isn't it? So square root of 84 is also not possible. So next is 5, so 5 square is 25, so 100 minus 25 is 75, so the square root of 75 is also not possible. So next is 6, so 6 square is 36, so 100 minus 36 is 64, and we know the square root of 64 will be 8, isn't it? So that's why the other element will be 6 comma 8. Alright, now similarly, if you go forth, you'll find that the next value for x will be 8, and 8 square is 64, so 100 minus 64 is 36, so square root of 36 turns out to be 6. Alright, next is the value of x has to be exactly 10. Okay, so it is 10 square, so 10 square is 100, so 100 minus 100 is 0, so square root of 0 will be 0, and 0 is also a whole number. So the next value will be 10 comma 0. So this will be the roster notation of this particular given relation. Next is we need to write the domain. So domain will be the set of first elements, that is 0, 6, 8, and next is 10. Alright, and the next one, that is the range, will be 10, 8, 6, 0, or you can write this in increasing order, that is 0, 6, 8 and 10. So basically we see that both domain and range turns out to be same in this case. So pause the video and note it down. Alright, now let me take question number 21. So 21 says, if A and B, these are the sets, find the elements of the subset of A cross B corresponding to the relation R is less than. Okay, so basically here you have to find the subset of A cross B. Okay, so A cross B is there and you have to find the subset of this. And what do we call the subset of A cross B? We call it the relation, isn't it? So R, the relation is what? Relation is a subset of A cross B. Now, how is this relation defined? This relation is defined, let R be the relation defined by, so it is defined by is less than. Okay, so it is defined by is less than. Now also represent this relation by an arrow diagram. So question says find the elements of the subset. So find the elements means what? We have to write down this relation in what? This relation has to be written in roster form. Okay, so let's see. So therefore the elements of R will be, okay, so let's see what will be the element. So it is given relation is defined as is less than. Okay, that means x is less than, or let me write it in this way. It will be better if we write in this way. So let's first write this in the set builder form. Okay, that is R is a relation containing x comma y such that x is less than y. Okay, so that's what the relation says. So x is less than y, where this x, the first element should come from it is a subset of A cross B, no? So that's why the first element should come from A. So X belongs to A and Y belongs to second set, that is B. Okay, so therefore the elements of R, so let's see what are the elements. So the first element is X, isn't it? So X should come from A. Yes, so if I choose 2, okay, so the next element, that is Y, has to be greater than X, isn't it? Y is greater than X, the other way around, isn't it? So let us see the numbers Y from B which are greater than X, that is the numbers greater than 2. So the numbers greater than 2 are 6 and 10. So that's why 6 will come here, and similarly 10 will also come along with 2. Okay, now let me choose other number from A, that is 3. So the numbers greater than 3 are 6 and 10. So again 3 6 and 3 10 will come here. Okay, next one is 6. The number greater than 6 here is only 10, isn't it? So only 6 10 will come here. So if I choose 10 here, then we don't have any number greater than 10 in B. So that's why only these many elements will be in this set, in this relation. Now the next thing is we have to depict this relation in a arrow diagram. All right, so we have the first set. Okay, so the first set is A, second set is B. So first let us write down what are the elements of A and B. So the elements are 2, 3, 6 and 10. Yes, so 2 is this, 3 is this, 6 is this, and 10 is this. Next is in B we have got 1, 6 and 10. So 1, 6 and 10 are there. So this is 1, this is 6 and this is 10. Alright. Now what is happening? Let's see here. So 2 is mapped with 6. Okay, so this is also called mapping. Alright. So 2 has to be mapped with 6. 2 is mapped with 10 as well. So 2 is mapped with 10. Next is 3. So 3 is mapped with 6 and 10. So 3 will again go to 6 and the 3 will go to 10 as well. Alright, so you have to show the arrow also. Okay, now next is 6. Now 6 goes to only 10. Alright, so 6 goes to 10 here. Now we don't have any other element here. So this will be the arrow diagram for this particular question. Alright, now this is the first question. Let's see the other question. So question says, this is question number 23. So question says, let A be the set. List the ordered pairs. So list means again we have to write the roster form satisfying each of the following relations on A. So the relations on A, that is from A to A, is given to be, okay, so these are the 3 different cases given. So let us take one case at a time. Okay, so in this case R is a relation defined by is greater than. That means that R is a set with element x comma y such that x is greater than y. Yes, and x y, since the relation is defined on A, so that's why both x and y should come from A. All right. Okay, so let us see what are the elements here. So if I choose one element x to be minus 2, okay, so the number greater than minus 2 are all these, isn't it? So minus 1 is also greater. So okay, I'm sorry. So x and y are related in this way, that is x is greater than y. And if I choose x equals to minus 2, now we must have the next number y to be less than x, isn't it? So if I read this way, this is y is less than x. Now I have to choose a number less than minus 2. Is there any number which is less than minus 2? We don't have. So that's why minus 2 cannot be taken the value of x. Okay, so let us take the value of x to be minus 1. Now is there any number, okay, if I choose the value of x to be minus 1, is there any number which is less than minus 1? Yes, so it is minus 2. Okay, so we have the next value is 0. So the number less than 0 is minus 1 and minus 2. So minus 1, 0, minus 2 will also come here. All right. So we have next is 1. So we have 1 comma 0. We have 1 comma minus 1. Next will be 1 comma minus 2, isn't it? And we have next is 2, and all these numbers are less than 2. So we have 2 1. Next is 2 0. Next is 2 minus 1. And finally we have 2 minus 2. Okay, so this is the relation which is greater than. Okay, so this is the relation that we need to find. Okay, so the next is r is the square of. So this relation can be written as x comma y says that x is the square of y. That means x is the square of y. So that's what is the meaning of this, where x and y both comes from set A. Now let's write this as the roster form. Okay, so if I choose y to be, see here, if I choose y to be minus 2, okay, or okay, so you choose y to be minus 2, then this becomes x equals to minus 2 whole square is 4. We don't have 4 here, isn't it? So x equals to minus 2, y equals to minus 2 cannot be taken. So next is y equals to minus 1. So if I choose y equals to minus 1, then minus 1 whole square is 1, isn't it? So the value of x turns out to be 1 if the value of y is minus 1. Alright. So if I take y equals to 0, then 0 is square is 0. So the value of x also turns out to be 0. So that's why 0 comma 0 is also possible. Now the value of y is 1. Now if the value of y is 1, then 1 square is 1. Again this 1 also comes to the set, isn't it? So if y is 1, the value of x is also 1. Now next value for y is 2. So 2 square is 4, and we don't have x equals to 4 in this. So that's why this will be the list of the relation R, which is defined by this particular phrase. Now at last we have R is the negative of. Alright, so this means R is the set with ordered elements, ordered pairs as such that x is equals to minus y. Okay, x is the negative of y, means x equals to minus y. Okay, where x and y belongs to A. Or what is the meaning of this? This means that if this comes over here, then x plus y equals to 0. That's what is the meaning of this. So we have, if I choose x equals to minus 2, okay, now we have to choose a number such that, see here, from here we got x plus y equals to 0, isn't it? So x plus y equals to 0 is there. So if I choose x equals to minus 2, then what number should be chosen for y such that my sum is going to be 0? The number has to be minus 2, and this y has to be 2, isn't it? Now do we have 2 here? Yes, we have 2. So the number will be minus 2 comma 2. Okay, so the value of x is minus 2 and the value of y has to be 2 here. Alright, fine. Now the next value for x is minus 1. Okay, so can minus 1 be taken out here? Yes. So because minus 1 plus 1 gives me minus 1 plus 1 gives me 0, isn't it? Okay, so this is also fine. Now the next value for x will be 0. Alright, so 0 plus 0 will also give me 0, right? 0 plus 0 will also give me 0. So that's why this is also fine. Now can you choose the value of x to be 1? Yes, because 1, if I choose the value of x to be 1, then the value of y has to be minus 1, and minus 1 is also present here. So that's why we have 1 comma minus 1 also present here. Similarly we have 2. So if I choose x equals to 2, then the value of y turns out to be minus 2. So this will be the set referring to the relation is the negative of. Alright, so you may pause the video and note down. Now let's take question number 25. So question 25 says, let R equals to this relation If a if the ordered pair a comma minus 2 belongs to this relation and 4 comma b square also belongs to this relation, then find the value of a and b. That's what the question is saying. Okay, so see, this is the given relation and this is also a part of this. That's what is the meaning of this, isn't it? Now this is my x, this is my y, isn't it? So if this is my x and this is my y, then this satisfies this equation, isn't it? Yes. So therefore we have y, okay, so y equals to 2x minus 4. Yes, and what is the value of y here? Y is minus 2 and x is how much? X is a, right? So from here we need to find what is the value of a. So we get 2a minus 4 is equals to minus 2. So from here if you calculate the value of a, this goes over there, becomes plus 4. Yes, so 4 minus 2 is 2. So 2a equals to 2 means a equals to 1. So we got the value of a. Now in the same manner this also belongs to this, so that's why the value of x is 4 and the value of y is b square. So y, that is b square, will be equals to 2a, and what is a? A is 4, isn't it? 2x in fact. Yes, so y equals to 2x, x is 4 minus 4. All right. Okay, so from here we need to calculate what is the value of b square. So we have 2 into 4 is 8 minus this is 4, right? So this is 4. So therefore b will be equals to square root of 4, isn't it? Now what will be the value of b? The value will b will be plus minus 2, because plus 2 is also integer, remember, okay, and minus 2 is also integer. So therefore there are two values for b and those values are plus minus 2. Okay, so there is only one value for a and there are two values for b, remember that. Now next is question number 26. Let me read the question for you. Question says, find the linear relation between the components of the ordered pairs of the relation. So there are two relations given to you. So this is first relation and this is your second relation. Now you need to find the linear relationship between the elements. That means if this is my x and this is my y, then what will be the linear relationship between them? Now remember, linear means you should be able to draw a straight line. Okay, and you already know that the equation of straight line contains two variables x and y. Okay, and the power of both x and y will be 1. Okay, that means the variables with power 1 gives you a linear equation. That's what you need to remember. Okay, so basically this ordered pair is acting like a coordinate for you and this also acting like a coordinate for you. So you have got x1 y1, you have got x2 y2. Okay, use these two and find what is the equation of that line. Okay, that will give you a linear relationship. Now after finding the relation, you have to verify this as well. How? Let's see. All right, so we have, let x1 y1 be minus 1 and x2 y2 be 0 comma 2. All right, so I'm just going to do only one part, the other one you will try by yourself. Okay, so therefore equation of the line joining x1 y1 and x2 y2 is, so the equation will be given by y minus y1 equals to y2 minus y1 whole divided by x2 minus x1 into x minus x1. So this is the formula, right? So this part I am not doing, you will try by yourself. Okay, so let's put the value now. So we have y minus y1. Now what is y1? y1 is minus 1, isn't it? So we have minus 1 equals to y2. y2 is 2. So 2 minus of y1. y1 is minus 1 whole divided by x2. x2 is 0 minus x1. x1 is how much? x1 is minus 1. So x minus x1, x1 is minus 1. Alright, so let's simplify this. So we have y plus 1. So this is 3 by 1, isn't it? So 3 by 1 is 3. So this is x plus 1. So simplify this, you will get that this is y equals to 3x plus 2. Alright. So this is the linear relation that we got from here. Now let's see whether this ordered pair is also being satisfied or not. Okay, so this is my x. So when x equals to 1 and y equals to 5, okay, then we have, okay, so left hand side is y, isn't it? So y, left hand side is y, so y is equals to 5, and RHS, that is right hand side, is 3x, x is 1 plus 2, and how much is this? This is also 5. So both are same, right? So that means if left hand side, that is x is 1 and y is 5, then we see that left hand side and right hand side both turns out to be equal. That means this equation is satisfied by x comma, I'm sorry, 1 comma 5. That means 1 comma 5 also lies in this line. Alright, so what's the meaning of this? This means that this is the required equation of line, or this is the required linear relationship. Okay, so at last you will write, therefore the required linear relation is, okay, y equals to 3x plus 5, okay, where x comma y comes from what? Comes from this relation. So at last you need to write this as well. So pause the video and note it down. Thank you very much.